Welcome to lesson 3.2, where we're going to be talking about conditional statements. So you guys have had conditional statements happen in your entire life. For example, if you want to go hang out with your friends and your parent says, if you clean your room, then you can go hang out with your friends, that is a conditional statement. The only way you can go hang out with your friends is if you clean your room. If you don't do it, then you don't get to go, right? So you've heard of conditional statements before, or for example, if I tell you, if you keep talking super loudly, then I'm going to write you up. That is a conditional statement. It depends on how you determine what happens with the condition will then determine what happens. So in math, we call that Q would be considered the hypotenuse, the if. If this happens, that's your hypothesis, then P. P would be your conclusion. So if I clean my room, then I get to go hang out with my friends. Hypothesis, if I clean my room. Conclusion, then I get to go hang out with my friends. So we use P and Q. That is just the variables they chose for logic and all of that. So if P, then Q. P is the hypothesis, Q is your conclusion. So if P, then Q. Okay, then we have different versions of that conditional statement. So the conditional statement is what we start with. So if P, then Q. P is your hypothesis, Q is your conclusion. Then we have the converse where you flip it. If Q, then P. So if I get to go hang out with my friends, then I'll clean my room. That would be swapping the hypothesis and the conclusion. Okay, so converse is when you just flip the statement. So for example, if we had, if I clean my room, then I get to go hang out with my friends. The converse would be, if I hang out with my friends, then I'll clean my room. Okay, and then we have the inverse and the contrapositive. Now, the inverse is when we change it. So the little squiggle right here and right here, that means not. Okay, so think about like opposite. So if not P, then not Q. So if I don't get to hang out, or if I don't clean my room, then I don't get to hang out with my friends, right? That would be the inverse. If I don't clean my room, then I don't get to hang out with my friends. So it changes both. It puts a negative connotation on both, or it switches them. So then the contrapositive is the converse, but it has the not. So if not Q, then not P. So if I don't go hang out with my friends, then I won't clean my room. Okay, so you take the negative of both of those and you switch them. Okay, so now we're just going to kind of work through some statements and rearrange and learn how to identify the hypothesis, the conclusion. So remember, the hypothesis is P, what you start with, if. Whatever follows if is your hypothesis. Then, after then, that's your conclusion, that's your Q. Okay, so now let's open up. So we have this table that we're going to kind of fill out. So first things first, if you live in New Jersey, then you live on the East Coast. So the first thing we're going to do is identify the hypothesis. So if you live in New Jersey, that's your hypothesis, right? That's after the if. Then you live on the East Coast. So now I have my hypothesis, my conclusion. So now I'm going to write the converse, the inverse, and the contrapositive. But first we need to determine, is this statement true or false? So if you live in New Jersey, then you live on the East Coast. That is a true statement. New Jersey is on the East Coast. Okay? Now, just because the conditional statement is true doesn't mean the other statements, when they get rearranged, are also true. Sometimes when you rearrange the statement, it changes the meaning, right? How you say things changes the meaning of what you're saying. And so it'll flip it. So if you live in New Jersey, then you live on the East Coast. So P is you live in New Jersey. Q is you live on the East Coast. So the converse is if Q, then P. So if you live on the East Coast, then you live in New Jersey. Okay, so that would be the converse of that statement. So if you live on the East Coast, then you live in New Jersey. Well, is that true or false? That is actually false, because you could live anywhere on the East Coast, right? Like New Jersey is not the only state on the East Coast. You could live in Florida. Florida is on the East Coast. So that is a false statement. So when we rearrange the statements, sometimes it changes the meaning of them. Okay, so the inverse, if P, if not P, then not Q. So if you don't live in New Jersey, so the P was if you live in New Jersey, so not P would be if you don't live in New Jersey. Then Q is you live on the East Coast. Not Q would be then you don't live on the East Coast. And so we have to ask ourselves, is that true or false? Well, it's false, because even if you don't live in New Jersey, you can still live on the East Coast, right? If you don't live in New Jersey, you could still live in Florida, and that would mean you live on the East Coast. So that statement would be false. Okay, and then not Q, not P. So if you don't live on the East Coast, then you don't live in New Jersey. So not Q, not P would be if you don't live in, if you don't live on the East Coast, then you don't live in New Jersey. And so we have to determine, is that statement true or false? And it is true, because if you don't live on the East Coast, then you for sure are not going to live in New Jersey, because New Jersey is on the East Coast. Okay, so that's kind of rearranging the statements, and we're going to do that for each one. So if a polygon is a rectangle, then it is a square. So the first thing we need to do is identify the hypothesis, which is a polygon is a rectangle. And then the conclusion, or your Q, is it is a square. Okay? And so if your polygon is a rectangle, then it is a square. That is false. Okay, because not all rectangles are squares, right? Some rectangles are, like if you have them where all the sides are equal, but that's not always the case. So the converse would be if Q, then P. So if a polygon is a square, then it is a rectangle, and that would be true, because if it's a square, then it's already a rectangle. Okay, that is true. Okay, so then not P, not Q. So if a polygon is not a rectangle, then it is not a square. And if a shape is not a rectangle, then it cannot be a square, so that would be true. Okay, because all rectangles are rectangles. All squares are rectangles, but not every rectangle is a square. Okay, so if the polygon is not a rectangle, we already know it can't be a square, because all squares are rectangles. And then the next one, not Q, then not P. So if a polygon is not a square, then it is not a rectangle. And that would be false, because even if it's not a square, it can still be a rectangle, right? So if I have the rectangle let me redo that. If I have the rectangle right here, and these are all 90-degree angles, which is what makes a rectangle, and this is 2 and this is 4, that's not a square, but it is a rectangle, right? So that would be a false statement. Okay, if two angles have a sum of 180 degrees, then they are supplementary. So the hypothesis is two angles have a sum of 180, then they are supplementary. So if the P is the angles have a sum of 180, Q, they are supplementary. So then my converse, if Q then P, so if two angles are supplementary, then their sum is 180. And so if we know that two angles are supplementary, then we know their sum is 180. So that would be a true statement. Okay, then the inverse is not P, then not Q. So if two angles do not have a sum of 180, then they are not supplementary. Okay, so if two angles do not have a sum of 180, then they are not supplementary. That's true. Oh, and I forgot to say, the conditional statement is also true. My bad. I forgot to write that. So both of so far we have all true statements. And then the contrapositive is not Q, then not P. So if two angles are not complementary, then the angles do not, oh, why did I say complementary? I'm sorry. I meant to put supplementary. Whoops. So if two angles are not supplementary, whoops. Then their sum is not 180 degrees. So if two angles are not supplementary, then their sum is not 180 degrees. That's true, because they have to be supplementary for them to have a 180 degree sum. So then let's look at the last one. So if two angles have the sum of 90, if two angles have the sum of 90, then both angles are acute. So acute, both angles are acute would be my Q, and then, or my conclusion, and then my hypothesis would be if two angles have the sum of 90. And so is that a true or a false statement? That's true. If the angles are have a sum of 90, then both angles are acute, because if their sum is 90, both of them have to be less than 90. So that means that they have to be acute angles, because acute angles are angles that are below 90 degrees. So now let's write the converse. So if two angles are acute, then they have the sum is 90. And so we have to think about that. Is that true or false? And that is false, because give me two acute angles that add to not 90, and that would be 60 plus 60. 60 plus 60 degrees is 120 degrees. Both 60-degree angles are acute, but they don't have a sum of 90, so that would be false, okay? If not P, then not Q. So if two angles are not, or if two angles, do not have a sum of 90, then they are not acute. They both are not acute. Right? And is that true or false? That would be false, because if they do not have a sum of 90, and that means that both of them can't be acute. Well, if I have an acute angle like 40 plus 80, one of them is acute, but one of them is, that's 120, and that's not a sum of 90. So if they do not have a sum of 80, and both angles are not acute, then that would not be true. So that's false. And then the last one, the contrapositive. So if both angles are not acute, then they do not have a sum of 90. And that statement is true, because if both of them are not acute, one of them has to be greater than 90 degrees, and so it's going to be over 90, so they could not have a sum of 90 degrees. So that's it for lesson 3.2. Bye.